This is the Canon PowerShot SX420 IS. Canon released it in 2016, and by then, smartphones had become the camera most people carried every day, so compact cameras needed to offer something a phone couldn't. For the SX420, that was a 42 times optical zoom. It could go from a wide 24mm view to a 1008mm equivalent telephoto. Today, zooming in feels completely ordinary. You press a button, the lens moves, and the subject gets closer. Simple. But it took more than a century of optical engineering to make that feel effortless. So while we take this camera apart, let's look at how the zoom lens evolved from specialized equipment into something built into an affordable camera like this. Before engineers could build a practical zoom lens, photographers had to work around a basic limitation. Changing the view usually meant changing the lens. For a wider picture, you used a wider lens. To bring a distant subject closer, you switched to a longer one. And if you didn't have the right lens with you, you either moved the camera or accepted the shot you could get. That worked, but it wasn't always practical. Photojournalists, filmmakers, scientists, and eventually everyday photographers all wanted the same thing, one lens that could cover more than one focal length. It sounds simple, just make the lens zoom, but optically it was anything but simple. Changing magnification was only part of the problem. The image also had to stay sharp, remain in focus, and stay properly aligned while the parts inside the lens were moving. For decades, engineers experimented with different ways to make that possible. Some early designs could change focal length but lost focus as they zoomed. Others were too large, too complicated, or too expensive for everyday photography. So the challenge wasn't just building a lens that could zoom, it was building one people could actually use. Early attempts at variable focal length lenses appeared more than a century ago. The basic idea was straightforward. Move groups of lens elements to change the focal length. The difficult part was controlling those movements while keeping the image in focus. In the early 1900s, inventors like Clyle Allen patented variable focal length lens designs. Those designs showed that the idea could work, but they weren't practical enough to see widespread use. A few decades later, engineers made another major step forward. In the late 1920s, Frank Back developed one of the first practical zoom lenses for motion picture cameras. A cameraman could now change the framing smoothly while filming instead of stopping to swap lenses. But zoom lenses were still large, expensive, and mostly limited to professional equipment. Another important breakthrough came in 1950. French engineer Roger Cuvier designed the first commercially successful zoom lens for still photography. Not long after, Pierre Ingenieur refined zoom lens design even further. His lenses became known for their optical quality and helped establish zoom lenses as serious professional tools. Even then, they were still far larger and more complex than anything most people would carry on vacation. Shrinking that technology into a compact camera would take decades of improvements in optics, mechanics, and manufacturing. Let's take a quick look inside one of the other systems packed into this camera. This small circuit board is part of the flash assembly. Its job is to take the camera's low battery voltage and convert it into the high voltage needed to charge the flash capacitor. Here you can see the entire flash system removed from the camera. The control board charges the capacitor stores the energy, and the xenon flash tube releases it in a bright burst of light. Even though the camera only runs on a small battery, this capacitor is rated for 330 volts. That's because a camera flash needs a tremendous amount of energy, but only for a fraction of a second. The capacitor slowly stores that energy, then releases it almost instantly into the flash tube. It's also one of the few components in a camera that can still hold a dangerous charge after the batteries have been removed. This tiny rechargeable backup battery serves a very different purpose. Instead of powering the camera, it helps preserve the internal clock, and likely some camera settings when the main battery is removed. Without it, you'd probably have to reset the date and time every time the battery went dead. Even after practical zoom lenses had been developed, they were still out of reach for most people. They were large, heavy, and mainly built for professional photographers and filmmakers. Over the next several decades, that slowly began to change. Lens designers found better ways to arrange optical elements. Manufacturing became more precise, and improvements in glass, coatings, and mechanical engineering made zoom lenses smaller, lighter, and more reliable. By the 1970s and 80s, zoom lenses were becoming increasingly common on consumer cameras. Instead of carrying several fixed focal length lenses, many photographers could cover a wide range of views with just one. That convenience made zoom lenses incredibly popular. As camera electronics improved, autofocus, automatic exposure, and eventually image stabilization made long zoom lenses easier to use. By the time digital cameras became mainstream, manufacturers were competing to offer longer and longer zoom ranges. Not because photographers suddenly needed to see farther, but because cameras could now provide that reach in a package small enough to carry in a bag or around your neck. The Canon SX420 IS is part of that evolution. Everything we're looking at here is the result of generations of refinement. Not one invention, but thousands of smaller improvements that gradually turned the zoom lens into an everyday feature. Canon had been building cameras for decades before digital photography became mainstream. And as zoom technology improved, the company saw an opportunity to bring longer lenses to everyday photographers. Instead of carrying interchangeable lenses, why not build a camera with one lens that could handle almost everything? Canon introduced the PowerShot series in 1995. Over time, those cameras gained longer zoom ranges, better image quality, and more advanced electronics. A major milestone came in 2004 with the PowerShot S1 IS. It combined a 10 times optical zoom with Canon's image stabilization system. That made handheld telephoto photography much more practical. Over the next decade, Canon kept extending the range. 10 times became 12, then 20, then 30, and eventually the 42 times optical zoom found on the SX420 IS. That lens covers an equivalent focal length of 24 to 1008 millimeters, wide enough for landscapes but long enough to photograph distant wildlife, aircraft, or sporting events. And the camera didn't get dramatically larger. The engineering just got better. That's exactly what we're about to see. Inside this compact lens assembly are dozens of parts working together to change the focal length while keeping the image sharp. Up to this point, we've been looking at the history of the zoom lens. Now we're looking at the engineering that makes this one work. The SX420's lens doesn't zoom by moving one piece of glass. Instead, multiple groups of lens elements move inside a set of nested barrels. Different groups perform different jobs. Some movements change the focal length, while others handle focus and help keep the image sharp throughout the zoom range. Making all of that happen requires extremely precise motion. That's why this lens is filled with tiny gears, guide rails, cam tracks, and electric motors. Every time you press the zoom lever, the motors turn the gears, and the cam tracks guide the moving groups along carefully designed paths. If even one part is slightly out of position, the camera can lose focus, the zoom can jam, or the lens may stop extending altogether. That's why these assemblies have to be built and aligned to such tight tolerances. And remember, the SX420's actual maximum focal length is only 180.6 millimeters. Its small image sensor gives it the same angle of view that a 1008 millimeter lens would produce on a 35 millimeter camera. That combination of a small sensor and a complex retracting lens is what allows this much reach to fit inside a camera weighing less than a pound. What once required large professional equipment now fits in the palm of your hand. With every part removed, it's easier to see just how much engineering is packed into this camera. From the outside, the SX420 IS looks fairly simple. A lens, a screen, and a handful of buttons. But inside are dozens of precision components working together every time you press the zoom lever. The motors have to move in the right sequence, the gears have to stay synchronized, and the lens elements have to follow carefully designed paths while keeping the image sharp. None of that happened overnight. Each generation solved another problem, making zoom lenses smaller, more reliable, and capable of reaching farther than the generation before. The SX420 IS wasn't the first Superzoom camera, and it certainly wasn't the last, but it shows just how far zoom lens engineering had come by 2016. Taking it apart gives you a different appreciation for everything happening each time that lens extends from the front of the camera. Thanks for watching, and I hope you enjoyed the video. If you did, please help support the channel by clicking the like button. I'll see you next time.